So let's look at this warm-up. Let's do the first row together. Obviously, the radius would be half of the diameter. The circumference would be pi d, or 2 pi r. And now is where we use our new stuff. We learned a proportion. We learned that it can be reduced, it can be simplified to just part over whole equals part over whole. So the length of AB, that's a part of the whole circumference. Circumference is all the way around. So I don't even need to memorize a certain formula or a proportion. I just have to know what to put together. I put the length of the arc over the length of all the way around the circle, and then I set it equal to whatever my angle is over all the way around a circle. So part over total equals part over total. Then we cross multiply, and we do not press the pi button. And we get 3, but make sure you multiply it by pi because we didn't press the pi button and pi is still there. Remember, anytime something's curved, it's going to have pi in it. Anytime something's not curved, it won't have pi. So don't be the student that puts pi in their answer for a radius just because they get so excited and they put pi next to everything. A radius would not have pi because a radius is a segment and not a curve. Okay, now let's look at the next part. We know that when it says that this is pi, we know that it's understood that there's a 1 in front of it. So that is 1 pi. So let's do our proportion. The length of the arc over all the way around. So we put the part over all the way around equals, we don't know the angle, over all the way around, degrees in a circle. The cool thing about this is that pi divided by pi will cancel, but you did need to know that there was an understood 1 sitting there. So you just do 1 times 360 divided by 6. So it's really just 360 divided by 6. So that is a 60-degree angle. And then, of course, we can do that quite quickly. All right, so finding the length of an arc of a circle is all about setting up a proportion. Yes, super easy. Let's look at that homework if you did it, if you're able to do it. This was your homework called arc length. It looks like, let me show you real quick. Looks like this, circumference and arc length. So the skills you needed for this was you needed to know that a central angle is equal to the measure of its intercepted arc, and you needed to know how to find arc length. So I just want to point out when we're looking at these answers, all of these answers down, all of these that have a pi in it, that represents an arc length. That's how long the arc is. It's not the degree of the arc, it's not the measure. It's not 30 degrees. That's how long the arc is. It's a distance. All of those are distances. Whereas these right here, these are angles, kind of. It's a measure. It's not a distance, okay? So I talked about how we as humans, we have a height and we have a weight. Those are 2 totally different numbers. You don't compare someone's height to someone else's weight. You would compare height to height and you would compare weight to weight. Same thing with measure versus length. Length is a distance, whereas measure is like an angle. So we're going to take what we learned on Friday, arc length, and we're going to translate it into area of a circle. We're going to go from 1D, from like the distance from A to B, that's 1D. We're going to go from that length to 2D. We're going to find the area of this piece of pie, and that piece of pie is called a sector. So we're going to take that exact same formula we were using and we're just going to tweak it to go from length to area. Let's do it. So remember, just a reminder that the area of a circle is pi r squared. I've heard a lot of my students are getting mixed up thinking it's 2 pi r squared, but you're like trying to combine the circumference and the area formula. It's just plain old pi r squared. We used 2 pi r squared when we were finding the surface area of a cylinder because it has 2 circles. But other than that, no, there's no 2 in front of it, okay? just pi r squared. So a sector is literally the pie-shaped region of the circle. That's not like the technical definition, but that's what it is. And the way that the variable we use is different. We haven't used subscripts a whole lot in this class, but the variable for area of the sector is ASEC. Kind of like SecNav, the Secretary of the Navy, SecNav. This one's ASEC, the area of a sector. So that's the variable we're going to use. Now, do you think that we could use the same proportion but just adjust it to work for area? What would we need to change if we're trying to find the area of the sector? I'll give you a hint. This is going to stay the same. I heard someone saying circumference should probably become the area. Instead of the distance around the circle, we're going to be shading in the whole circle. This is going to stay. We're still going to use how much, because don't you agree that to find the area of that piece of pie, you need to know what the angle is that you're opening up. The smaller the angle, the smaller the area. The larger the angle, the more pie you get to eat. We're not going to use L. What variable is going to go there? And then right here we would put the area of the sector. That's messy. I have it not messy right here. So go ahead and add this to your notes. The area of the sector over the area of the circle equals m over 360, where m is still the measure of the angle. How much are you opening up? What is the angle of that opening? Because the larger the angle, the larger the area. So ASEC over A equals m over 360. These are not on your formula chart, so technically you're memorizing them. But remember, if you just know the common sense of it, part over whole equals part over whole, then you're not really memorizing anything. Okay. Why not try some? So we're going to find the area of this sector. Let me highlight it so it looks prettier, like we're actually finding the area of something shaded. Let's do the first one together. So I always set up an empty proportion. That's what I do always, and then you can start filling it in however you want. The angles go together. This is an angle, this is an angle. So you always put the angles in the same column. Always. Never mix them up. That degree sign, sorry, now it looks like an 8. Let's fix that, Miss Tanton. I think my alignment of my board is a little off. Okay, now what goes on the other side? The area of the sector goes here, but we don't know the ASEC. And the area of the circle, pi r squared. So 144 pi. Just pretend I wrote that right there. So in our calculator, we will do 144 times 30 divided by 360. The area of the sector, if you just put 12, it'll get marked wrong on the test. You did all that work. You have to put pi. If you want to put meters squared after it, that would be great. This one was meters squared too. You cannot forget the pi though. 12 pi is the area of the sector. 12 pi square meters. Okay, let's try this next one. Set up your proportion. I usually do my angles first because those are easy, and now I know I've kept them together in the same column. The area of the circle this time is 81 pi because we square 9. So the denominator here is 81 pi, and that's ASEC. So we're doing our cross multiplying again. 81 times 120 divided by 360. 27 pi inches squared. This would be 81 pi inches squared because these are areas. Areas. Just let me say one extra thing just to show you where the background of this formula is from. Some people take the 120 and they divide it by 360, and they know that, oh, this right here is really just a third. So what I'm doing when I find the area of a sector is I'm just taking the area and I'm taking 1/3 of the area. I realize that we set it up as a proportion and we cross multiply, but you're really just reducing the one on the right or your left or whatever, and then you're just finding 1/3 of the total. So 1/3 of 81 is 27 because I want 1/3 of the area of the circle. because 120 is a third of 360. I hope that helps you understand the proportion a little bit more. Quan, usually they're shaded. In these examples, they're not shaded for some reason. Usually the sector is shaded. But if it's not shaded, you're always going to assume it's the smaller. It's not. We don't really do reflex angles in this class. A reflex angle is greater than 180. We could if we needed to, but we usually look at the angle that's less than 180. Okay? All right. Next one, we're going to be working backwards here a little bit. It tells us that the area of this sector is 5 pi. So we're still going to set up our normal proportion. We don't know m. 360 still goes here. The area of the sector is 5 pi, and then down here is the area of the circle. So pi r squared. We know the pi's are going to cancel. So now we can just cross multiply with the 5 and the 360 and the 36. 5 times 360 divided by 36. So what is the measure of that angle? It is a 50-degree angle. Last one. We're looking for the radius this time. Well, last one on the screen, not last example. This is the last on-level example, then I have a K-level example next. Okay, so I like to put my angles first. Angle, total degrees in a circle. And now we do know the area of the sector. Usually that's our variable, but we know it this time. And this is, I'm just going to put A. That's my placeholder. All right, pi's don't cancel anywhere yet. So I'm just doing 4 times 360 divided by 160. And that gives me A. The area of that circle is 6 pi. I read my number upside down on my calculator. Wow. I haven't done that yet. 9 pi. I was like, wait a minute, 6, that doesn't have a perfect square root. It's not a perfect square, so I knew something was wrong. All right, so how do we go from area, which is pi r squared, to just radius? Well, we divide by pi, and then we do the opposite of squaring something. We square root. So, of course, the radius of the circle is 3. So we divide by pi. You don't need that anymore. And then we take the square root. The opposite of squaring something is square rooting. Okay, let's try this fun one. Kind of looks like a radioactive symbol or something. Find the area of the shaded regions. Okay, regions, depends on how you look at it. I'm going to give you all time to think about it before I start working it. So there's a few ways to approach this problem. We could find the area of just one of those sectors and multiply it by 4, or we could just add up the angles and not have to multiply anything. What did y'all steer towards? Did you find the area of one and quadruple it, or did you add up the angles that those would consist of? Angles. Well, let's do it both ways. So the first thing that we can do is we can assume that all the white ones are 60 if you want to. And so if I were to use M as all 4 of those, there's a little bit of lag, sorry about that. So we would take 60 times 4, and we would subtract it from 360. All 4 of those add up to 120. All 4 of these add up to 120. Now, if you want to divide it by 4 and just say that these are each 30, you could do that as well. You could say that they're each 30, and then later when you find the area of the sector, you can multiply it by 4. But I'm going to keep it at 120. That way we're finding the area of all of them at the same time. So you know that 360 always goes in the denominator. That doesn't change no matter what. We don't know the area of the sectors, but we do know the area of the circle. We just have to take 18 and square it, and we get 324 pi. So now we will cross multiply. 120 times 324 divided by 360. So what is the area of the shaded region? Tahir, that's not fully right. Yes, good. 108 pi. Sorry, I don't know why I did that. Square inches. It's because y'all type pi 108 pi, there we go, square inches. Cool. Keep going. All right, we have to learn one more thing today. This is the K-level part. I don't even teach this in L-level. This is kind of counterintuitive. A segment of a circle, when it's of a circle. A segment is the part of the circle, I'm just reading this off, bounded by the arc and the segment joining its endpoints. So we have a chord. We have a chord. And we have an arc, whether it's major or minor. And the shaded region between that chord and that arc is called a segment. And I know it doesn't look like a segment, and no, it is not one-dimensional. It's an area, it's 2D. But this is a segment of a circle. So it's not a plain old segment. This is just what it is. So that is a segment. Now, how are we going to find the area of a segment? Think about it. How are we going to find the area of that shaded region? Yes, Abby. So here's how we're going to find the area. First, we're going to draw radii. We're going to draw these so that we can form a sector, a piece of pie. So we're going to find the area of the sector. We're going to find a sec. Then we're going to find the area of this triangle, area of a triangle. And then we're going to subtract them. And when you find the area of the piece of pie minus the area of the triangle, then you'll get the area of the segment. It's called a segment. Crazy, huh? So sector minus triangle. I'm going to give you a minute to write this down if you're taking notes. Let's see if we can put this to use. Find the area of the shaded region. So we're going to find the area of that peach region. And the way that we're going to do that is we're going to find the area of the sector. And then we're going to take away the area of the triangle. So let's get started. Let's find the area of the sector. To find the area of the sector, we're going to do a sec over a equals m over 360. I hope I'm not going too fast because we've already learned this. Let's wait for the screen to catch up because there's a major lag. There we go. So 100 times 90 divided by 360, and we get that the area of the sector is 25 pi. Now let's find the area of the triangle. Now, we started off with an easy one because I gave you a right triangle. It's not only right. What else is it? Because this is a radius, and this is a radius, these triangles that we draw, they're always going to be isosceles because these triangles are always made up of the radii. But they're not always going to be right isosceles, but they will always be isosceles. So the area of that triangle is base times height divided by 2, and so it's minus 50. And that is the answer. It looks like we have those the wrong way, right? Like, ooh, I should switch those. But no, you should not. 25 pi is greater than 50, so the answer is 25 pi minus 50. You don't subtract them, you don't combine them, you don't do anything unless the problem says to round. You might want to put units on it. It would be inches squared because it is an area. Okay? Find the area of the shaded region. Same strategy. A sec minus area of the triangle. So we are going to do a sec over area equals m over 360. Huge lag, sorry. 36 times 120 divided by 360. So the area of the sector is 12 pi. Now we're going to find the area of the triangle. Now remember, this is isosceles. It is. Because it always is. But we cannot just do 6 times 6 divided by 2 because the height is not 6. So we're going to have to get creative here. We're going to have to draw the height in just like that. So if you want to redraw the triangle facing you, you can. Remember that the measure of an arc is equal to the measure of the central angle. We need that measure or else we can't find the height of this triangle. Now, when I take 120 and I draw the height in, what happens to the 120? It's bisected. So, this is 60, this is 90, and this is 30. Oh my goodness, you thought we were done with those. Okay, so anyways, what is the height of this triangle? We okay with the height being 3? So now we need our base. Our base is a lot. It is. This is 3 root 3, and this is 3 root 3. So the base is 6 root 3 times height divided by 2. So those 6's, those weren't the base or the height. Okay, is it showing up? It's being so slow. So what would that be? 9 root 3? pi minus 9 root 3 is the answer. Now this is looking like the area and perimeter unit. Oh no. It won't get any harder than this one. I mean, I promise. Okay. So please make sure that you try your homework, especially try the ones on your homework that are segments, because we obviously have the toughest time with that piece of it. Tomorrow you better ask me questions. We'll go over questions and we'll move on. Tomorrow is tangents. You will like it better than area of a sector, I promise.